November 12, 1943. Luftwaffe Technical Intelligence Center, Rechlin, Germany. The metallic ring of the empty drop tank echoed through the cavernous hangar as it rolled across the concrete floor, propelled by the boot of Hauptmann Werner Vogel, who stood with his hands on his hips, staring at the cylindrical object as if it were a message from an alien civilization. The late autumn light filtered through the hangar's high windows, illuminating the battered P-51 Mustang that sat in the center of the facility, its aluminum skin scorched and punctured from the flak that had forced its pilot to bail out over Belgium 3 days earlier. But Vogel's attention was not on the fighter itself. It was on the 2 teardrop-shaped containers that had been mounted beneath its wings, containers so unremarkable in appearance that they seemed almost comically simple compared to the sophisticated machinery of the aircraft they had served. The sound that dominated the space was the deliberate tapping of Dr. Friedrich Hartmann's fountain pen against his clipboard as he completed his preliminary measurements of the drop tank's volume, wall thickness, and structural characteristics. Each tap punctuated a calculation, a notation, a growing recognition that what appeared to be crude auxiliary fuel containers actually represented a revolution in aerial warfare logistics as profound as any technological advancement in engine design or armament. The pen's rhythm was methodical, almost mechanical, the audio signature of German scientific precision encountering a problem it had not anticipated and a solution. It had not imagined that American engineers had solved the range limitation of escort fighters not through exotic propulsion or aerodynamic wizardry, but through brute force simplicity, disposable fuel tanks that extended operational radius by hundreds of miles at minimal cost in weight, complexity, or production resources. Dr. Hartmann, a pre-war aeronautical engineer from the Technical University of Munich, who now served in Luftwaffe Technical Intelligence, ran his hand along the drop tank's aluminum skin, feeling the rivets and seams that spoke of rapid mass production rather than precision craftsmanship. The tank was crude by German engineering standards, visible tool marks, inconsistent rivet spacing, welds that would have failed inspection in any German aircraft factory. Yet this crudeness was itself revealing. These tanks were not precision instruments designed for reuse and careful maintenance. They were expendable, manufactured in such quantities that pilots could jettison them without concern, could treat them as consumables rather than carefully maintained equipment. The implications cascaded through Hartmann's analysis with the inevitability of a mathematical proof arriving at an unwelcome conclusion. He lifted the clipboard and began writing his preliminary assessment, the fountain pen scratching across paper in the distinctive sound of German bureaucratic documentation. External fuel capacity, approximately 75 gallons per tank. Combined with internal fuel, estimated combat radius extends the P-51 to approximately 650 miles from base. This places Berlin within escort range from English airfields. He paused, pen hovering over the page as the full strategic implications crystallized. There was no German city beyond reach now. No target too distant for American heavy bombers to strike with full fighter escort. The sanctuaries that distance had provided, the deep interior of the Reich, the eastern industrial centers, the southern production facilities, all had become vulnerable in the time it took American engineers to design a disposable aluminum tank and American industry to produce them by the thousands. This moment, German technical intelligence, recognizing that American fighters equipped with drop tanks could escort bombers throughout German airspace, marked a fundamental shift in the air war over Europe. It represented the collision between 2 different industrial philosophies, 2 approaches to engineering problems, and ultimately 2 competing visions of how modern warfare should be waged. What the German scientists discovered in examining those drop tanks was not just a technical solution to a tactical problem, but evidence of an industrial and institutional capacity that operated according to principles fundamentally different from those that had guided German war production. The crude aluminum containers spoke of abundance, of industrial processes that could produce equipment in quantities so vast that sophistication became unnecessary, of a military-industrial complex that could afford to treat complex manufactured items as disposable commodities. To understand why the drop tanks revealed so much about American capabilities and German vulnerabilities, one must first comprehend the strategic situation that made escort fighter range the critical variable in the air war over Europe. The American commitment to daylight strategic bombing, launched in earnest during 1942, had been predicated on the belief that heavily armed B-17 and B-24 bombers, flying in tight defensive formations, could fight their way to targets deep in Germany without fighter escort. This doctrine had been tested and found catastrophically inadequate during 1943, as Luftwaffe fighters inflicted unsustainable losses on unescorted bomber formations. The famous Schweinfurt-Regensburg raid of August 1943 and the second Schweinfurt raid in October had seen bomber losses exceed 20%, rates that would destroy the entire bomber force within months if sustained. The fundamental problem was range. Early American escort fighters, P-47 Thunderbolts and P-38 Lightnings, had insufficient range to accompany bombers to targets in central and eastern Germany. Fighters could escort bombers partway, but at some point the escorts had to turn back, leaving the bombers to continue alone into the teeth of German fighter defenses. The Luftwaffe, recognizing this pattern, developed tactics that conserved fighters until the American escorts turned back, then attacked bomber formations with overwhelming force. The result was a strategic stalemate. American bombers could not reach distant targets without prohibitive losses. Yet those distant targets included the most critical elements of German war production. The P-51 Mustang, introduced as an escort fighter in late 1943, possessed range characteristics that promised to solve this problem. Equipped with the British Rolls-Royce Merlin engine, produced under license in America as the Packard 5.1650, the P-51B combined excellent high-altitude performance with impressive fuel efficiency. But even the Mustang's internal fuel capacity, approximately 270 gallons, provided range insufficient to escort bombers to Berlin and back, a mission requiring approximately 2,300 miles round-trip flight. The solution was conceptually simple but practically challenging. Add external fuel tanks that could extend the fighter's range, then jettison those tanks before engaging in combat. The technical challenges of external fuel tank design were considerable. The tanks had to be aerodynamically clean to avoid excessive drag. They needed to integrate with the aircraft's fuel system, feeding fuel to the engine while maintaining proper aircraft balance and handling. They required quick-release mechanisms allowing pilots to jettison them when entering combat. They had to be manufacturable in large quantities by industries that might have no experience with aircraft production. And critically, they had to be economically disposable. If fighters jettisoned tanks on every mission, the tanks needed to be cheap enough that losing thousands of them monthly remained sustainable. American engineers solved these problems through a combination of technical innovation and industrial pragmatism. The drop tanks adopted streamlined teardrop shapes that minimized drag while maximizing volume. They were constructed from aluminum alloy, the same material used in aircraft construction, using techniques adapted from other manufacturing processes. Fuel feed systems use proven technology from internal fuel tanks, with emergency shutoff valves ensuring pilots could isolate external tanks if necessary. Release mechanisms employed simple mechanical latches that pilots could actuate from the cockpit. Most importantly, the entire design emphasized simplicity and manufacturability over optimization and elegance. The production scale was staggering. By late 1943, American industry was producing drop tanks by the tens of thousands monthly, manufactured by companies ranging from aircraft suppliers to firms that had never touched aviation components before. The tanks were shipped overseas with fighters or sent separately as cargo, stored at airfields in quantities that seemed almost reckless to German observers accustomed to carefully husbanding resources. American fighter groups used drop tanks as routine expendables. Every escort mission saw hundreds of tanks jettisoned over Europe as fighters engaged German interceptors. The tanks fell into forests, fields, rivers, and cities, becoming a peculiar form of litter that testified to American material abundance. Hauptmann Vogel, watching Dr. Hartmann complete his analysis, understood the implications with the clarity that comes from professional expertise meeting unwelcome truth. Vogel had been a Luftwaffe fighter pilot, with over 200 combat missions before being transferred to technical intelligence, following wounds that left him unfit for combat flying. He knew intimately what it meant to intercept American bomber formations, knew the tactical calculations involved in attacking heavy bombers, and knew how the presence or absence of escort fighters transformed those calculations. with P-51’s escorting bombers throughout German airspace. Luftwaffe fighter tactics would need complete revision. The previous approach, waiting for escorts to depart before attacking bomber formations, would become impossible. German fighters would face American escort fighters over every target, at every altitude, throughout the mission profile. The fountain pen's tapping resumed as Hartmann calculated fuel consumption rates, mission profiles, and operational ranges. The sound punctuated the analysis, each tap marking another data point, another recognition of how thoroughly American material advantage had manifested in these crude aluminum cylinders. The drop tanks were not technologically sophisticated. German engineers could design equivalent systems, had in fact developed their own drop tank technology for limited applications. But the scale of American production, the casual expendability of the tanks, the institutional commitment to providing them in quantities that treated them as consumables rather than equipment, these aspects spoke of industrial capacity and military logistical philosophy that Germany could not match. Dr. Hartmann's analysis would be compiled into a technical intelligence report that circulated through Luftwaffe Command, Reichsluftfahrtministerium, Aviation Ministry technical offices, and eventually to Albert Speer's Armaments Ministry. The report documented the drop tank specifications, analyzed their operational impact, and drew strategic conclusions about American industrial capability. But beneath the technical language and bureaucratic formatting, the report communicated something more disturbing: that American industry could produce sophisticated auxiliary equipment in quantities so vast that German production could not respond effectively, that American operational doctrine treated complex manufactured items as disposables, and that the material asymmetry between American and German war production was widening rather than narrowing. The sound of Hartmann's fountain pen became, in this context, a symbol of German technical competence in countering problems it could document, but not solve. German engineering excellence, precision manufacturing, and scientific rigor, all the institutional strengths that had made German industry a world leader, were being overwhelmed by an opponent whose advantages lay not in sophistication, but in scale, not in precision, but in abundance, not in optimization, but in the brute force application of industrial capacity, so vast that crude solutions implemented at massive scale outperformed elegant solutions implemented at limited scale. German fighter production in 1943 was approximately 15,000 aircraft annually, a figure that would grow to over 30,000 in 1944 under Speer's rationalization programs. These numbers seemed impressive until compared to American production, approximately 38,000 fighters in 1943, rising to 51,000 in 1944. But the asymmetry extended beyond aircraft numbers to include all the supporting equipment, ammunition, spare parts, and auxiliary systems like drop tanks. American factories produced not just fighters, but the entire ecosystem of equipment and supplies necessary to sustain high-tempo operations at continental distances from home bases. German production focused on aircraft themselves, with auxiliary systems often treated as afterthoughts, and with chronic shortages of everything from spare engines to ammunition to fuel. The drop tanks exemplified this asymmetry. They were simple objects, not complex machinery, yet producing them at scale required industrial capacity, raw materials, transportation infrastructure, and organizational coordination that Germany increasingly lacked. Aluminum was in short supply in Germany by 1943, diverted primarily to aircraft production, with little available for auxiliary equipment. Manufacturing capacity was strained, producing fighters, bombers, and other combat aircraft with limited industrial plant available for accessories. Transportation networks were increasingly disrupted by Allied bombing and by the demands of moving military equipment to multiple fronts. The institutional coordination required to manufacture, distribute, and supply consumable equipment like drop tanks demanded systematic logistics that German war production never achieved. Vogel examined the drop tank's mounting hardware, noting the quick-release mechanism's simplicity. A pilot could jettison the tanks with a single control action, allowing immediate transition from cruise configuration to combat configuration. This operational flexibility was itself significant. American fighters could fly long-range escort missions with the fuel capacity to reach distant targets, then fight with full maneuverability after jettisoning external tanks. German fighters attempting similar operations with external tanks would be committed to carrying those tanks throughout combat, accepting the aerodynamic penalties and handling degradation that external stores imposed. The strategic implications cascaded through multiple levels of analysis. At the tactical level, Luftwaffe fighters would now face American escorts throughout the operational envelope, unable to exploit the range sanctuary that had previously existed beyond escort fighter range. At the operational level, no German target was beyond reach of American heavy bombers with full escort protection, forcing defensive fighter forces to be distributed throughout Germany, rather than concentrated at key industrial areas. At the strategic level, the air superiority that the Luftwaffe had maintained over much of German airspace was ending, replaced by American air superiority extending from the English Channel to Poland, from the North Sea to the Alps. Dr. Hartmann's report would document all these implications with Teutonic thoroughness, but the conclusion was inescapable. The drop tanks revealed that America possessed industrial capacity and logistical sophistication to support sustained strategic air operations at ranges that made all of German-controlled Europe vulnerable. The tanks themselves were merely aluminum cylinders, but they represented industrial systems and institutional capabilities that operated at scales Germany could not match. They were evidence, material and undeniable, that the United States was fighting an industrial war according to principles of mass production and systematic logistics that American industry had pioneered in civilian contexts and now applied to military production with devastating effectiveness. The fountain pens, scratching continued as Hartmann completed his analysis, each stroke adding to the documentary record, each sentence building toward conclusions that were technically accurate and strategically devastating. The report would be filed, circulated, read by officers and officials who would recognize the implications and who would understand that countering this threat required resources and capabilities Germany did not possess. Some would recommend development of German drop tanks, a recommendation that would encounter the same resource constraints and production limitations that affected all German war production. Others would suggest tactical adaptations, doctrinal changes and operational adjustments that might mitigate the impact of American escort fighters. But beneath all these responses was the recognition that Germany faced an enemy whose material advantages were so overwhelming that tactical skill and operational excellence could no longer compensate. The P-51 Mustang with its drop tanks represented the maturation of American strategic thought about air, power and industrial warfare. American doctrine had evolved from the pre-war belief that strategic bombers could operate independently, through the painful recognition that fighter escort was essential, to the systematic solution of extending fighter range through auxiliary fuel tanks produced at industrial scale. This doctrinal evolution was enabled by institutional flexibility. American military organizations could recognize doctrinal failures, could adapt strategies, and could implement solutions that required massive industrial mobilization. The drop tanks were not just technical artifacts, but evidence of institutional competence, of organizations that could identify problems, develop solutions, and execute implementation at scales that changed strategic balances. German institutional culture, by contrast, had become increasingly rigid under Nazi totalitarianism. Technical innovation continued. German engineers developed remarkable technologies including jet aircraft, guided missiles, and advanced radar. But systematic implementation of simple solutions at massive scale was impeded by bureaucratic dysfunction, competing power centers, and Hitler's personal interventions in technical and strategic decisions. Germany could produce marvels of engineering like the Me-262 jet fighter, but struggled to manufacture sufficient drop tanks to extend conventional fighter range. The asymmetry revealed by those captured drop tanks was not just industrial but institutional. American organizations functioned more effectively than German equivalents at translating requirements into production at operational scales as Hauptmann Vogel and Dr. Hartmann completed their examination of the drop tanks. As the fountain pen finished its methodical notation of specifications and implications, the sound that dominated the hangar was a profound silence, the silence of recognition, of understanding that the air war's trajectory was determined not just by aircraft performance or pilot skill, but by industrial capacity and institutional competence that Germany could not match. The crude aluminum cylinders lying on the hangar floor spoke louder than propaganda, communicated more clearly than intelligence reports, and revealed with geometric certainty that American fighters would soon escort bombers to any target in Germany, that Luftwaffe defenses would be overwhelmed regardless of tactical adaptations, and that the strategic bombing campaign, that had seemed stalled in mid-1943, would soon intensify to levels that would systematically destroy German war production. The report that Dr. Hartmann completed documented these conclusions with scientific precision. It would be classified, distributed through appropriate channels, filed in archives where post-war historians would eventually find it and recognize its prescience. But the report's immediate impact was limited because the problems it identified had no solutions within Germany's constrained resources and dysfunctional institutions. Luftwaffe commanders reading the report understood that American escort fighters with drop tanks would soon dominate German skies but lacked the fighters, pilots, fuel, and ammunition to prevent this. German industry could theoretically produce drop tanks, but lacked the aluminum manufacturing capacity and organizational coordination to do so at scales that would matter operationally. The Nazi leadership could read technical intelligence about American capabilities but could not create the institutional reforms and resource allocations necessary to respond effectively. The drop tanks became, in German consciousness, a symbol of American material abundance and industrial sophistication. Soldiers and civilians across Germany would eventually see hundreds of these aluminum cylinders scattered across the landscape, jettisoned by American fighters as they engaged Luftwaffe interceptors or as they returned to England with excess fuel. The tanks became scrap metal, were collected for recycling, were sometimes repurposed by civilians for water storage or other improvised uses. Children played among them, soldiers cursed them as evidence of enemy abundance, and technical personnel studied them as object lessons in design philosophy. Each tank was a message from an enemy whose industrial capacity seemed limitless, whose logistics functioned with mechanical reliability, and whose approach to warfare emphasized overwhelming material superiority over operational artistry. The fountain pen that Dr. Hartmann used to document his analysis became, metaphorically, the last instrument of German technical competence, capable of recognizing and analyzing threats but unable to provide solutions, able to document problems with precision, but powerless to prevent the consequences. The pen's scratching sound as it filled pages with calculations and conclusions was the sound of German expertise encountering the limits of what expertise alone could achieve. Technical excellence, scientific rigor, and analytical precision were necessary but insufficient when facing an opponent whose advantages were fundamentally industrial and institutional rather than technical. By early 1944, P-51 Mustangs equipped with drop tanks were escorting American bombers to Berlin, to oil refineries in Silesia, to ball-bearing plants in Schweinfurt, to every target that strategic planners identified as critical to German war production. The Luftwaffe attempted to contest these missions, launched fighters against the bomber formations, and engaged American escorts in battles that gradually depleted German fighter strength faster than training programs could replace losses. The air superiority battle that developed through 1944 was essentially decided by winter. The Luftwaffe remained operationally active but could no longer prevent American bombers from striking targets throughout Germany with acceptable losses. The drop tanks were not solely responsible for this outcome, but they were critically enabling. Without the extended range that external tanks provided, American escorts could not have protected bombers to distant targets. Strategic bombing would have remained limited to targets within unescorted range, and the air war's trajectory might have been different. With drop tanks produced by the tens of thousands, distributed systematically and employed routinely, American fighters achieved the range necessary to contest airspace over Berlin itself, eliminating the distant sanctuary that had previously limited strategic bombing effectiveness. Hauptmann Vogel's final action before leaving the hangar was to kick the empty drop tank one more time, watching it roll across the concrete with a hollow metallic sound that echoed in the empty space. The sound seemed to mock German technical intelligence, to laugh at the analytical precision that could recognize problems but not solve them, to announce that the war would be decided by industrial capacity rather than tactical brilliance. Vogel understood that his own combat experience The skills and knowledge he had accumulated over years of operational flying were becoming increasingly irrelevant as the air war transformed into a battle of attrition that Germany could not win. The drop tank rolling across the floor was a herald of defeat, an aluminum messenger bearing news of inevitable strategic failure. Dr. Hartmann filed his report, completed his bureaucratic obligations, and returned to the analytical work that technical intelligence demanded. But the drop tanks remained in his memory as exemplars of a particular form of American engineering philosophy. That simple solutions implemented at massive scale could overwhelm sophisticated solutions implemented at limited scale. That disposability enabled by abundance could provide operational advantages that precision design could not match, and that industrial warfare rewarded systematic mass production over artisanal excellence. These lessons would influence post-war German industrial development, would shape European understanding of American economic capacity, and would contribute to broader recognition that the United States possessed not just military power but industrial and institutional capabilities that operated according to principles different from European traditions. The sound of the fountain pen completing documentation, the metallic ring of the drop tank rolling on concrete, the silence of recognition as German technical experts understood the strategic implications. These sounds became the auditory symbols of a moment when material evidence contradicted ideological certainty, when technical analysis revealed uncomfortable truths, and when the trajectory of the air war over Europe became clear to those willing to see. The drop tanks were simple objects, crude by German standards, unimpressive in their engineering. But they represented something Germany could not counter: an industrial base capable of producing auxiliary equipment at scales that treated sophisticated manufactured items as disposables, a logistics system that could distribute supplies across continental distances with systematic reliability, and an institutional culture that could identify problems, develop solutions, and implement those solutions at speeds and scales that changed strategic balances. In the broader context of World War II, the drop tanks exemplified how material abundance and industrial capacity translated into military advantage. The war was ultimately won not by technical sophistication or tactical brilliance, but by the industrial power's ability to sustain operations at unprecedented scales, to replace losses faster than enemies could inflict them, and to maintain logistics networks that supplied frontline forces with everything they needed, regardless of distance or difficulty. The United States, with its vast industrial base and systematic approach to mass production, excelled at this form of warfare in ways that Axis powers could not match. The drop tanks rolled across the hangar floor at Rechlin in November 1943, but their echoes would reverberate through the remaining years of the war and into the post-war era. They announced that American fighters could reach any target in Germany, that strategic bombing would intensify to levels that would systematically destroy German industrial capacity, and that Luftwaffe fighter forces would be ground down through attrition they could not sustain. But beyond these immediate military implications, the drop tanks communicated broader truths about industrial civilization, about how democracies mobilized resources and organized production, and about the fundamental reality that in modern warfare, industrial capacity and institutional competence mattered as much as courage, skill, or tactical excellence. The fountain pen's final scratch marked the completion of Dr. Hartmann's report, the last notation in a document that would be filed, archived, and eventually forgotten except by historians seeking to understand how Germany perceived the growing American threat. But the insights that the drop tanks provided about American industrial capacity, about institutional competence, about strategic approaches to aerial warfare, these insights would persist, would shape post-war understanding, and would contribute to broader recognition that the United States had emerged from World War II not just victorious but as a power whose industrial and institutional capabilities operated at scales that redefined what modern nations could achieve when fully mobilized. The crude aluminum tanks that seemed so unimpressive in their engineering were ultimately more historically significant than the sophisticated fighter they served. They were the physical manifestation of American abundance, the tangible evidence of industrial capacity that could not be matched, and the harbinger of strategic defeat that no amount of German technical excellence could prevent.